Hello students, so today we will learn about Bohr atomic model, which is also known as quantized atomic model. So this model was not a very new model developed from scratch, but it was an improvement of the previous model. What was the previous model? It was the Rutherford's atomic model. So Bohr model was an improvement of the Rutherford's atomic model. So Rutherford atomic model was having some drawbacks, and atomic stability explanation was one of those drawbacks. So I think you know that in Rutherford's atomic model, it could not explain the atomic stability because according to the Max Planck's quantum theory, when a charged particle is in accelerated motion, it radiates energy. So when electrons are revolving in circular orbit around the nucleus, so they should radiate energy because electrons have charge, and in circular motion every particle has centripetal acceleration. So electrons should radiate energy, and after radiating energy the orbit radius of the electrons should decrease with time like this, and finally the electrons should fall into nucleus, and this way the atom should get destroyed. But this doesn't happen. So Rutherford's atomic model could not explain the atomic stability, and this was one of the major drawbacks present in Rutherford's atomic model. So this Bohr atomic model was an improvement of Rutherford's atomic model. So Bohr atomic model borrowed some points from Rutherford atomic model and added some new more points to complete the model, present the model of the atom. So let's write about the points given by Bohr atomic model. So first point was borrowed from the Rutherford's atomic model, which says that whole positive charge and almost whole mass of atom is concentrated at the center of atom. And what did Rutherford call this center? He called it nucleus. So whole positive charge and almost whole mass of atom is concentrated at the nucleus of the atom. And what about negative charge electrons? And Rutherford model says that negatively charged electrons revolve around the nucleus in circular orbits. So this point is same as given by Rutherford's atomic models. There was nothing new into this. But after this, Rutherford added few more points. So next point added by Bohr was, so if you remember, Rutherford did not mention anything special about the circular orbits. So according to Rutherford atomic model, there can be any circular orbit around the nucleus in which electron can revolve. He didn't put any restriction on the orbit. There can be infinite number of orbits anywhere around the nucleus. But Bohr put some restriction on the orbits. Bohr model says that electrons do not revolve in any of the circular orbits. So Bohr says that electrons revolve around the nucleus in only those circular orbits in which their angular momentum is whole multiple of h upon 2 pi. What is h here? H is Planck's constant, and value of Planck's constant is 6.6 into 10 raised to the power minus 34 joule second. So I will write it more. So if electron has mass m, suppose I draw a picture here. This is the nucleus of the atom, and suppose these are the orbits around the nucleus in which electron revolves. Suppose this is electron, its mass is m, and suppose it is revolving around the nucleus with velocity v, and the radius of the orbit, say this is small r. So what will be the angular momentum of the electron? Angular momentum of the electron will be m into v into r. In physics you learn about angular momentum, that it is the moment of linear momentum. So r cross p or r into p is the linear momentum, so r into m into v, so it becomes mvr into sine 90 will become 1. So mvr is the angular momentum of electron, and this should be whole multiple of h upon 2 pi, so this should be equal to nh divided by 2 pi, where n will be 1, 2, 3, 4 and so on. So here it is n is whole multiple. If you notice here, it says that whole multiple of h upon 2 pi, so n will be whole number, not integer, it will be whole number. So n is equal to 1, 2, 3, 4. Okay, so this is one major point given by given by Bohr, which was not present in Rutherford atomic model. After this, third point given by Bohr says that while revolving in an orbit, electrons do not absorb or emit any energy So he called these orbits as stationary orbits or stable orbits. So electrons do not absorb or emit any energy while revolving in any of these circular orbits. This was also one important point, and it added to the stability of the atom. And last point I would add here, that was given by Bohr. It says that electrons can make transition from a higher to lower orbit or lower to higher orbit. By emitting or absorbing energy. So suppose in this picture, I will add more space here. So I will add a picture. So suppose this is the nucleus of the atom, and there are two orbits around this nucleus. Suppose I say this is the lower orbit n1, and this is the higher energy orbit n2. So far away from the nucleus the orbit is, more will be its energy. So suppose electron which was revolving originally in n2 level, so it is coming to lower energy level n1. So when it is coming from higher energy level to lower energy level, it will radiate energy, it will emit energy, and it will emit energy in energy packets, those we call photon. So it will emit energy in the form of photon, and each photon has a characteristic wavelength or frequency. So suppose energy level of this n2 orbit is E2, energy level of the lower orbit is E1. So photon emitted here will have how much energy? It will have E2 minus E1 amount of energy, and this energy will be equal to h times nu, where nu is the frequency of the emitted photon, or if you want to write this formula in terms of wavelength, then it will be hc divided by lambda. What is h here? H is Planck's constant, as I told before, and c is the speed of light, which is 3 into 10 power 8 meter per second, and lambda is the wavelength of the emitted photon. So here energy is emitted in the form of photons which have characteristic frequency nu or characteristic wavelength lambda. So Bohr also derived a formula for this lambda, and for this third point, electron can make transition from a higher to lower orbit or lower to higher orbit by emitting or absorbing energy. You can add one more word here, respectively. So when it is coming from higher to lower orbit, it will emit energy. When it is going from lower to higher orbit, it will absorb energy. So for this characteristic wavelength, he gave the formula that 1 upon lambda, this 1 upon lambda is also known as wave number, and it is represented by symbol nu bar. So nu bar is the wave number, which is equal to 1 over lambda, and the formula derived by Bohr was this is equal to r z square in bracket 1 upon n1 square minus 1 upon and 2 square. So what is R here? R is here known as Rydberg constant. Rydberg's constant, and its value is 1.09 into 10 raised to the power plus 7, and unit is per meter. Okay, and what is Z? So Z is here atomic number of the atom. So one very important drawback of this Bohr model was that I did not tell you. So one very important drawback of this Bohr model was that it was applicable only for hydrogen-like species. What are hydrogen-like species? Hydrogen-like species means uni-electron species, means those species which have only one electron. What can be one electron species? Like hydrogen atom. So hydrogen atom has only one electron. Similarly, single ionized helium atom, He plus, that can be also uni-electron species. Similarly, Li double plus or beryllium triple plus. So yeah, so Bohr model, actually Bohr derived many mathematical expressions, and it was the first model. It was the first model based on mathematical proofs. So this model was based on mathematical proof. That's why this model was quite successful, and it was successful for a long time. So that was the main reason for the success of this model. It was based on mathematical proofs, and still you are taught this model, so that proves the success of this model. Anyway, so I was telling you the drawback of this model, that this model is applicable only for hydrogen-like species. So in this formula was given by Bohr, and he derived it, and in another video I will explain you how this expression comes. So this is formula for wave number. So in this formula, using this formula, you can calculate lambda wavelength, and if you get 1 upon lambda, then you can put into this expression to get the energy difference, Hc divided by lambda. This you can calculate. Okay, so one more thing, last thing I would like to tell you, this model is also known as quantized atomic model. Why it is called quantized atomic model? Because this model says that the energy of the electrons when they are revolving in an orbit, that is quantized. This is not like continuous. So when an electron is revolving in one orbit, suppose in this orbit, its energy is E1, and another orbit that has energy E2. So these E1, E2 are fixed. So when electron has energy E1 or any energy between E1 and E2, it will always stay in E1. Can never go in between these orbits. Electron will never be present in this middle of the two orbits. As soon as it will have E2 amount of energy, it will go to this second orbit. So nothing will be in between these two orbits. Electron has whatever energy E1 or less than E2, E1 and any value between E1 and E2, it will always be in the first orbit. As soon as it has E2 energy, it will go into the upper orbit. So that is the main reason it is called quantized. Like when you are going to watch movies, suppose this is the movie screen and there are 3 rows. One row is very close to the screen, and the row middle row, and there is the balcony or the upper level rows. So suppose the cost for this upper row is $50. Cost for this price for this middle row is $30, and price for this first row is $10. So if you have $10, you will get the place in first row. Even if you have $20, you will get space in the first row only. Even if you have $29, you will get space in the first row only, not in the second row. But for getting a space in the second row, you need to have $30. So as soon as you will have $30, you can get space here. So whatever amount of dollars you have between $10 and 30, you will always be placed in the first row. Nowhere space is there in between these two rows. Similarly, even if you have $49, you will get space in this middle row, not in the third row. For getting space in third row, you need to have $50. Same thing applies for electrons also. So that's why this model is known as quantized atomic model. So I hope you enjoyed this Bohr atomic model. and the important points of this model. So if you are enjoying my videos, if you like them, please like my videos and subscribe my channel and share these videos with your friends also. So that's all I wanted to share with you people today. So take care, bye bye, and thank you very much.